All right, if it looks like there's a lot going on in part F of example 3, that's because there is, but that's okay. What we're going to do is try to make this look as simple as possible, and one of the things that can help with that is taking this cosine cubed e to the 5 theta and just simply writing it as cosine of e to the 5 theta and raising that entire function to the third power. That's what cosine cubed means. Now, honestly, this is a step that you can skip, but if it helps you, this is something that can make things seem less confusing. It's one less thing to think about. So now I can begin to apply my chain rule. Now you may have noticed that I have inside functions, outside functions that are inside other outside functions. We have nested functions here, and that means that I'm going to apply the chain rule multiple times, but that's okay. We're just going to do this one step at a time. So let's apply the power rule first to the outermost function. And so power times base down 1, we have 3 times our base, and we'll fill that in. And so power times base down 1, 3 minus 1 is 2. Now let's go ahead and fill in our inside function. So that was cosine of e to the 5 theta. And of course I need to multiply now by the derivative of the inside function, which was cosine e to the 5 theta. So that's going to be the derivative of the outside function, which here is the derivative of cosine. And the derivative of cosine is negative sine. That's right, negative sine. And that's still going to be the negative sine of e5 theta. That hasn't changed. So e to the 5 theta. Okay, but now I need to take the derivative of the inside function, which was e to the 5 theta. So you may recall that the derivative of e to the x is e to the x, and the general exponential rule was e to the g of x is g prime of x times e to the g of x. So in this case, my g of x is 5 theta, and so I need to write the derivative, which is e to the 5 theta times the derivative of this inside function 5 theta, which is just simply going to be 5. All right, now all we need to do is just put all this together and clean it up. And so 3 times 5 is going to be 15 times this negative sign gives me a negative 15. And that's going to be sine of e to the 5 theta times cosine e to the 5 theta. All right, but remember this was cosine e to the 5 theta squared. So let me return that square back down to the cosine function. And this will give me my final derivative, negative 15 sine e to the 5 theta times cosine squared e to the 5 theta. So that will be our final expression. All right, now in the next example, example G, we're dealing with a natural log. So you may need to remember the rule for taking the derivative of natural log. The derivative of ln of u is just simply 1 over u, where u can be any expression, or in this case, a quadratic function. So we'll be back in just a moment to check your answer to part G.